So this is my first time presenting at DevNation Federal. I was pleasantly surprised at the content we had and the amount of people that showed up. My name is Zohaib Khan, and I work for Red Hat. I've been at Red Hat for about 4 years. And I've been running a program called App Modernization, now working in NAP's team. And basically what that means is that we have been working with the customers to help modernize their portfolio of applications. And part of this is, my team specifically works with the customers in the field. And we have been doing this for I joined Red Hat like about 4 years ago. And after the first year, we started seeing like customers have these massive portfolio of applications. And sometimes they want to come to open source. And other times they want to go to cloud all the way. Really, like it was like total chaotic. And with the work that we have done, I've tried to distill that way of approaching this into the distinctive patterns. So today I'm going to talk about why modernization is important. I'm pretty sure that a lot of you already know the benefits, but just to illustrate what that looks like and also talk about the patterns and how do we actually do that for our customers. So let's get started. So everybody has seen the cloud adoption, I guess, or new technology, emerging technology adoption curve. Generally, like for agencies and enterprise IT, is usually lagging, as you can see. Whereas everybody else tries to, like if you look across the board, like everybody's using newer technology, but the enterprise IT is usually the last one. It is considered a negative, but really the dynamics over here is, it is because enterprise IT and especially agencies adopt emerging technologies towards their maturity, and even when the ROI is clear, right? If you look at like containers, for example, like containers started like back in the day, like some people argue they were there in Solaris and AIX, that type of thing. But as containers, we know in the form of Docker today, like if you go back 3 years, that was a new thing, right? And companies who are at the cutting edge started looking into it and started adopting it. But it was really not clear from the enterprise IT or agency tech's perspective that what is the value, is this a stable technology, and whether are we going to get ROI, or is this just another VM? Like, everybody was trying to adopt VM still and trying to get the value out of it. So as the technology matures and the ROI becomes clear and the benefit actually materialize, that's when we see the massive ramp up happens. So people say that we have to modernize, and we have to modernize like without thinking about it. But I say that let's be a little pragmatic about it, like not just follow the hype. So for me, like the way I've seen is that first of all, modernization is about enabling experimental approach to product delivery, right? Which basically means that we all have these legacy systems like mainframe systems. I'm pretty sure like your agency or the company you work for, have a massive footprint of legacy apps. 9 months release cycle, that's very typical. Anybody does better than 9 months, like 6 months, 3 months? Okay, so that's really the reality, right? And if you are in that situation, for you to test an idea and put it in front of the customer, get the customer's feedback, and refine your product, year and a half, in the best case scenario, right? But what does that mean? If there's a mandate coming from the government, or if there's a requirement that you have to meet real quick, we all scramble to fit that in. But most of the time, we will take the safest approach. What is the approach that we will take to not take off the security guys, not embarrass, the business, and what is the minimum thing that we can do to put something out? And pretty soon, you end up with a user interface that looks like very, very unusable, right? And you will not have users actually use it. Whereas in terms of modernization, we actually turn it on its head. What we say is that we will actually take an experimental approach to product delivery. Something like you get your app out in front of the users so that they can start to use it right away and give you the feedback. That's not to say that you basically cut through the security layers or all the procedures, but have an innovative way to actually do things and still meet those requirements, right? Also optimize for speed versus the cost. So most of the IT shops today are optimized for cost, which means that we have siloed teams, we have cross-functional teams, and a lot of SI footprint that come in and actually set up shop. And most of them are siloed, like database teams, developers, testers, so on and so forth. But the reality is that they don't talk to each other until the release happens, right? Whereas what we want is to optimize for speed, which means that we want to create a culture in which people actually create like 2 pizza box teams, for example, that own the entire life cycle of the software delivery process, so which actually enables teams to deliver faster. So that does not mean that we have to, eat up the cost or this is going to be expensive, but it's just a different way of doing things. And also, this could be a catalyst for organizational transformation, right? So some things like frequent deployments, faster recovery from failures, short lead times are generally the side benefits that you get with something like this. And this is what I really tell my customers is like, don't think of modernization as replacing somebody's job. Think of modernization as doing IT in today's world where customers actually expect you to be here and give them a release every 2 weeks or so, right? So that they can see something quickly and you can refine it and deliver value. But when we talk about changing systems, it's really hard, right? The reality is that we can talk about modernization all day, but it's not going to make a difference because, first of all, organizational inertia, which means that skills, processes, and systems that are set up and the mindset in which we actually think are kind of fixed. So whenever we talk about creating new functionality, for example, right? Okay, let's get the project going. Let's get the funding. Let's create a big requirements. Let's get that approved first. And then once that is approved, then we will actually start maybe assembling the teams and start writing the code, so on and so forth. And nothing wrong with that. It's basically how we have actually started doing IT. But that's something that actually gets in the way sometimes, right? So that's one reality. There are also sizable investments in IT today. And to be frank, many agencies and many customers would like to leverage that instead of throwing that away. So if you have massive databases of customer information or of your, let's say, for your agency, whatever data you collect, you have a mainframe database that has this massive information. You cannot just throw that away and expect like some other new technology to take it over magically. So what do we do with the investments that we have? And if you don't bring that into the equation, then usually it becomes a moot point, right? And also, modernization is uncharted territory, which means that if you are not very clear about the benefits, you do not specify, you do not articulate to the business that what the benefits they're getting, it's really like, okay, yeah, this is just another mainframe retirement project, and we have done tens of those, but mainframes are still around, right? It becomes one of that. And also, like the business perception is like modernization projects are usually sink for IT costs. Like, everybody comes out with the modernization story, but really, we are still running those mainframes that we said we are going to retire 10 years ago, right? So just wanted to point that out. I'm sure you might have seen this graphic in different formats before, but really what I wanted to point out is we have actually come from application lifetimes where it took years and decades to build systems and years and decades to actually run them, right? And the technologies that power them and the processes. So for example, we all developed those systems in monolithic architectures on mainframes, writing COBOL, IMS database, so on and so forth, use waterfall release process. We had our data centers and also like deployed on physical servers like, physical boxes, right? Then came the push where we started delivering writing systems in weeks and months and ran them for years, right? And some of the processes and technologies that powered that change, we all moved to Agile or start experimenting with it. Everybody has their own flavor of it. N-tier systems, virtual servers, so on and so forth. And now it's the paradigm of, get something out the door quickly in days and run it for weeks before something new will come up, right? And the processes and the methodologies and the technologies that are powering that are DevOps, microservices, and containers. Now, this is not to say that you have to actually adopt everything over here to actually be able to do this. This is laying out that this is the entire IT landscape, and you can find your agency doing different things. So you may still be doing, let's say, physical servers or virtual servers, but you still want to do microservices, for example, right? Or you're doing N-tier architectures on physical servers and physical database, but you are actually delivering in weeks and months. So the goal is to basically find what that balance is for your IT needs and where you are in that journey. Not to say that, okay, we are doing DevOps now, even though we were doing waterfall, and now we are doing microservices, even though we are somewhere over here. That's a major change, too fast, right? So what we have to look for is what makes sense. If we are still developing monolithic apps, so maybe we should experiment with this first before we jump here. So what does that transition looks like? So let me just illustrate that what modernization looks like with some example that I've seen very frequently. So generally, like, we have a big release plan, and I've seen some plans like that takes like hour to read, actually. I don't know who writes it, but there are people who write it, right? Once that happens, the development activity is something that happens in parallel, let's say. So you have a bunch of developers who can go and fiddle around with different parts of the system, and that's probably the only activity that happens in parallel in the entire release train. So once the development activity is finished, then we go into this massive synchronized activity, which we call QA integration, UAT testing, or like a testing, and we give months for that, right? And then finally, if everything goes well, fingers crossed, there is a new release that gets deployed. And this entire time frame is what, like 6 to 9 months, roughly, right? But what happens, let's say, if we find bugs? If we are lucky, we will find bugs here, somewhere over here. So fixing them is short time, short cost, not very expensive. But if we find bugs here, okay, we're still doing QA, we're still doing UAT. We can throw it out to the developer and say, okay, just fix it. And another release cycle, 3 months passed, okay, fine. Sometimes like 3 weeks, so on and so forth. But then if we find bugs in production, that is the most expensive thing, right? You have to shut down the system, or you have to go damage control, fix the defect, emergency release, go out and deploy it. And if you do that, then the next release that is coming in this release train has to stop, because you have taken out the release train for the emergency fix. So all the developers have to drop what they are doing, pick up this, fix it, and then you have to go through this QA cycle again, right? Now contrast this with something like, if we had some, let's say, in some shape or form, independently deployable services. So in this paradigm, you have a release plan for different services that can be deployed independently of each other. So they are not necessarily coupled into the same release plan, because they can actually go on their own time frame. So let's say you have a Java app, you have some Node.js app that you want to experiment with and get in front of the customer quickly. But when that application matures, you really want to bring into the fold of Java, which is more stable for your needs, let's say. But as you can see, developers can choose their own technology based on the job at hand. So if there's something they want to experiment with and test the idea, they can probably write it in Python, get it released quickly, get it in front of the customer. And also, like, there's no blocking in terms of, like, if one service has to change, then it's that service release cycle that gets impacted. You're not massively blocking. And that actually translates to the environments, that translates to the release cycles, that translates to testing. So everything is done for that particular set of services. Now, what about bugs? So if we find bugs, if there's a bug found in there, that's the service that gets fixed. This entire release cycle is not hijacked we do not block everybody else in this picture. So I know that this is a simplistic way of laying it out, but the benefit of this type of approach is, just adopting this mindset will free you from, this massive timelines that we have to contend with, in terms of, what we develop today. So much for the benefits of modernization. How do we actually do it, right? That's the real question, and that's something that we have been working with our customers. So there are 3 patterns that I started to recognize in the field when I started doing this. As you can see, lift and shift, refactor, and complete rewrite. So the way these patterns differ is, how do we start? So where do we start from? So generally, we apply lift and shift to the set of systems that are well architected, have clean separation of concerns, and we want to take them from where they are to like a container-based microservices, platform, for example. We have a class of legacy applications, let's say, that are monolithic in nature, mainframe, for example. How do you tear mainframe out and make modern system out of it? I'm going to show you how that looks like and the rewrite. So let's do a quick walkthrough. So as I said, lift and shift, we start with a well-architected system with clean separation of concerns. And let's say this is where we want to go. So the first thing that we do is we actually convert the runtimes of the application, which can be independently deployed, into, let's say, something called containers on a container-based platform. What you're doing is that you're not shutting down your system. You are just merely converting the runtimes into container form, but you're not changing the database, you're not changing the configuration, you're not changing the messaging or any of that infrastructure that goes along with it. The benefits of that is you're not telling the business that give me 6 months, 9 months, and a big check, and I will go and rewrite and shut down the system in the process, right? We are actually, what we are saying is that we will deliver value on day one as soon as we convert this, make this conversion. And usually this conversion is measured in weeks, not in months, right? And what we do is that we run something on top of like OpenShift platform, and business sees that the value that we have actually taken the existing app, have not made any single code change, just repackaged it into container and deployed it, right? The benefit of this first step is like you get self-service, you get automation, you get CI/CD out of the box, and those are the things that can actually reduce your time to market right away. Even though you haven't changed much in their application, but now is the time for you to start making those changes. Which brings me to the next step, where once you get onto this intermediate step, now you can say, let me isolate that customer bit and start converting that into a microservice. And since I already have a container platform, I will deploy that as a full-blown microservice over there. Let me take this, other, vertical concern and make a service out of that too. And in that process, you're not shutting down the system. You are actually inventing while transforming your system, right? So there is no business disruption from that standpoint. So that's lift and shift. The second pattern I talked about was refactor-based modernization, and this applies to systems that are monolithic in nature. So most of the mainframe, most of your legacy, which is very hard-coded and stored procedure-driven type of systems, they fall into this category. And it's really a hard problem to deal with if you look at it. Like, it's not easy to extract that code base from mainframe COBOL or that stored procedure and somehow make a microservice out of it. So the methodology that we recommend is do not change the system, keep it running where it is. But start to treat this as a backend, right? But you have to do 2 things. One, create two incisions for this system. One for the functionality, another for the data. So that I can, let's say you create some web service interface on top of it or a messaging interface on top of it. And you can send a message or you can invoke a web service that will register a customer for you and give you a response. And then you will also have the ability to query that data from it. So you are not changing the system. You are just allowing the system to be used from the outside. And you build the new functionality on the new platform, let's say container-based platform, and deploy like a pass-through microservice. So just with this type of approach, you are not shutting down your legacy system, which is hard to deal with, but you are running it. People know how to run it, but you are delivering new functionality in this new platform and delivering business value on day one, right? And this type of step, this type of transformation is measured in months, like few months, 2, 3 months. you can actually get up and running very quickly with this. And again, you're not telling the business that I'm shutting it down and I'm going to do a massive rewrite. You're delivering the value. So this was the first step. The second step is once you are here, then you can start taking vertical concerns and start building the specialized services that will eventually lead you to this desired pattern. Right? And this is very common that I see in the field today, especially with the mainframe systems around. The third is rewrite. So this applies to systems that are going out of support. We have developers that do not have that skill set anymore, or things that generally we don't want to continue to do. So for example, if you have hardware from back in the day, like 30 years ago, and the vendor does not support it, or you don't have people who know that language, you have to retire it, but do it in such a way that you achieve feature parity. So this is where we actually get lost most of the time. Like we have all started mainframe projects back in the day, but mainframes are still around. The reason is that we have not taken a methodical approach to actually take in an inventory of the functionality that exists in this world and mapped it to the new world. What I mean by that is achieve feature parity. So the way this needs to work is you document your features and you inventory those features and go in front of the business and say, I have these 10 features in mainframe. How many do you want in the new one? And they say, OK, maybe 7, right? Then you cross off those 3 that are not needed. And you take feature by feature and start implementing that. And as soon as you implement those 7 features that are needed, you retire the system. And you claim this cost. Otherwise, you will be running 2 systems for the price of 1. Usually doesn't happen that way, but you will continue to put more money into this. And that is also very important because people don't generally realize that rewrite becomes a massive technology cost sink. So how these approaches compare with each other, if we plot that on cost of migration versus the time it takes to deliver, generally people think that rewrite is the easiest thing to do. Well, it's easiest to get started, but hardest to finish or longest to finish because of the feature parity thing that I mentioned. Because if we don't map that feature, then somebody was going to stand up and say, hey, I have this database that I continue to use with my green screen and I need it. You cannot take that away from me. And guess what? You will continue to pay for those licenses then, right? Whereas if we compare augment and lift and shift, generally these are the ones that we try to map and see if we can apply these patterns. And sometimes one system can take part lift and shift, part augment. And this is where most of the action happens in our experience, right? Where we take the existing system and start to transform it from inside out. There are scenarios that this is needed, and we are very explicit about it. So that's what it looks like. This is not just us coming in and doing this thing from ground up for you. We have tools that we have developed. So one of our tools is Application Migration Toolkit. And what happens is that we take a portfolio of application and funnel it through this toolkit, and also sit down with your team to understand the systems better. And what happens is that this tool actually gives us a good indicator of how likely we are to modernize the system to cloud native from legacy. So using that as an approach, we start to score systems and put them in different buckets. And for each bucket, we have an action plan of how do we actually approach it. So sometimes a set of applications would require one type of approach. Let's say mainframe green screens are very notorious. People want to retire mainframe, but they don't want to let go of their green screens, right? How do you deal with that problem? You create a bucket for it, and you come up with an approach. And I've dealt with these scenarios. Customer database is in IMS, and nobody wants to move away from IMS because they are scared, right? How do you deal with that kind of scenario? So we actually map it out in terms of the portfolio. And this roadmap, like I put together for one customer, that turned out to be very useful. So in terms of starting point and the desired state and where you lie in this spectrum of 3 patterns, what actions do we actually take in terms of, so for example, if your system is a good candidate for lift and shift, we actually enable you for the open source first, assuming that you are coming from non-open source stack, right? So we enable on the open source stack, and then we get the container platform set up and get the team trained on that, and then we start doing that transformation. But similarly, if you're doing, let's say, refactor, so we take a mainframe monolithic app and create those integration points first, and then enable on the container platform and start doing that transformation. This is a generic framework, and what we do is that as part of the engagement or as part of working together, we map this roadmap to your specific needs. So we take actually application by application and say, application A, it's a candidate for lift and shift. And we are going to start from this point. This is the transformation we'll apply, and the end state is that. And we will do that for, let's say, the first 2 years. And usually that's the horizon that we start with. That's a good starting point. Sometimes agencies like to plan for next 5 years, and I've seen that too. Usually my advice is that use a planning horizon as much as you can see, and then make some assumptions for the future. So a 2-year plan like this will give a very good starting point, and also give you a very actionable set of items for your modernization needs. So I mean, this talks about how we actually do it in customer engagement. So we have a proven approach to deal with this. This is how our consulting teams operate. And we actually create a factory, modernization factory, for a massive portfolio of apps. So some agencies that I'm currently working with have 300, 400. Some have thousands of apps. And they just don't want to deal with them piecemeal. They want an approach and they want to use the SIs that they already have. So we usually go in and do this analysis and give them this entire roadmap and set up the factory in which the result of the analysis actually feed the functioning of the factory. Different migration teams or modernization teams can start to work in parallel, and this all feeds with the center of excellence and knowledge base. So I know that this was a whole lot of information, but we have done this with several government agencies that I'm not at liberty to name, but there are. This year I actually presented at Red Hat Summit with one of the biggest commercial customer we had, Verizon, and we have actually applied lift and shift for them, and they were happy to co-present with us. Yes.
Does your process include any kind of reverse engineering tools?
Reverse engineering as in?
Any kind of software that will actually take the mainframe code and reverse it into something more palatable. Say, for instance, your functions, your processes, your
right. So there are certain open source tools available that take the COBOL copybook and convert into Java objects, and we use that as starting point. But the thing is that we are just not mechanically changing things. We have to keep the business context too. So if the COBOL code, let's say, has a lot of things going on, not just one single concern, then just converting them to Java is not going to do you any good. Like you are taking the same baggage and repackaging it into the new language. So we start with that, but we analyze and see, okay, are we getting a single concern service, or are we getting like a same service that is monolithic in nature? And that's when we actually start to break it down. So it's a combination of tools plus our methodology that we apply in that paradigm. Any other question? Yes.
In my experience, a lot of the federal agencies have tightly integrated applications. How do you cherry pick applications when there are so many interdependencies?
So you mean just initially, or like when we are actually doing a massive modernization?
When you're doing your initial plan.
Okay. So initial plan is we request representative sample, which means that if you have 300 apps, we are definitely not going to pick 300 apps for the first cut. We will require 2 of each. So we actually look at the inventory, and this is where we work with the agency, and we ask them for 2 pieces of information. Tell us the stack that this application is running, and tell us the complexity of the application. And they usually give us a list, and we sit down with them and say, okay, this is one category, this is second category, this is third category. And once we have identified the categories, we say, okay, let's pick 1 of each or 2 of each. And usually we end up with a list of 15, maybe 20, and that forms our initial set. And even if that is too big, Then we scale it down to just 3, just to prove a point that this can be done. And once we get started with, let's say, 3, that becomes a good success starting point within the agency to catalyze, act as a catalyst, and other teams will start to, look at it and start to work with it. Well, you can reach out to me after this talk. So if you have any questions, I will be happy to answer them. Thank you.